Today on Flipping Science, we're going to be looking at solving simple titration questions. The process for how to do that is, first things, you need to find out what you know. Second, you need to find the number of moles of one of the reactants. Then you need to find the ratio between that number of moles and the other reactant, and then from there you'll be able to find the concentration of the second reactant. That's basically what you'll have to do. So here's an example question. So the first thing we're going to do is look at what we know. So we've got a solution of pure potassium hydroxide, that's important. Contains 3.32 grams of the potassium hydroxide in 100 mils of water. So using phenolphthalein indicator, 25 mils of that solution required 21.4 mils of a sulfuric acid solution. So sulfuric acid is important. So what I've done, I've underlined all the important parts of this question, so then we can get started. So, reading the question again, I'm thinking in my head what's happening. So, I'm starting with potassium hydroxide solution. So this is my standard solution. Taken 25 mils of that solution, put it in, and I've titrated that against some sulfuric acid solution. So now I have a fairly good idea about what's going to go on. So now we can start doing parts of the question. Now we'll continue to part A of the question. So write the equation for the titration reaction. So we need to write down the reactants. So we've got potassium hydroxide and sulfuric acid as our reactants. If you want to see how I got the formula for potassium hydroxide, have a look at my previous video on finding the formula of ionic compounds. They're going to react together to produce potassium sulfate and water. Again, if you want to know how I figured out the formula of potassium sulfate, check out the video. Alright. Now we need to balance it. We have one potassium here, two potassiums down here, so I'm going to need two potassium hydroxides. If we look at the total number of hydrogens I have, I've got two here and two here, which makes 4 in total. So that means I'm going to need 2 water molecules. Everything else should be balanced, I think. So one sulfate group, two potassium, two hydrogens, 4 hydrogens, 2 4 hydrogens. Right, so now we have our ratios between our reactants. We've got 2 potassium hydroxide, 1 sulfuric acid, goes to potassium sulfate, and 2 water molecules. So I'll balance the equation. Now we'll go to part 2, calculate the concentration of the potassium hydroxide solution. So to do this, we're going to need to find the number of moles of potassium hydroxide in the 3.32 grams. Alright. Now we're going to continue on to part B. We're going to calculate the concentration of potassium hydroxide solution. So to do this we need to use the information in the question. So we're going to use our mass of potassium hydroxide, and we'll have to calculate the molar mass of potassium hydroxide to figure out the number of moles. So the formula is N equals M on big M. Number of moles equals the mass divided by the molar mass. Our mass is 3.32 grams, and our molar mass, we need to look up potassium hydroxide, so grab our periodic table, find potassium down here, 39.10, then we need to look up oxygen, so oxygen over here, 16, plus hydrogen, which is 1.008. Alright, so use the relative atomic masses on the periodic table to find the molar mass. Chuck that in our calculator, so we got 3.32 divided by, make sure you put a bracket around it, the bottom down here. If you don't, you'll get to the wrong answer. Alright, so our answer on the calculator is 0.059 moles. Alright, so that's our number of moles of potassium hydroxide. The question says, calculate the concentration of potassium hydroxide. So to find the concentration, we need to have a number of moles and divide that by a volume. So we've got 0.059. We'll divide that by the volume. It's in exactly 100 mils of water. We need to turn that into litres. So 100 mils of water is 0.1 of a litre. So chuck that in the calculator. You probably don't need the calculator for that one. So we should get 0.59. Okay, so I'm going to 2 significant figures because it's at least now up here. So 2 significant figures, 0.59 moles per litre. Right, so that's part B. We calculated the concentration of the potassium hydroxide solution. Now we need to calculate the number of moles of potassium hydroxide neutralised. So, part C, what we're going to do, so back to the question, we used 25 mils of this solution here to neutralise the sulfuric acid. So we need to figure out the number of moles of potassium hydroxide in 25 mils of this solution. So to do that, formulate C equals N on V, we're looking for N. So rearrange the equation, we get N equals CV. Our concentration we just calculated in part B is 0.59 moles per litre. And our volume is the 25 mils that we used when we compared it. So 25 mils is 0.025. Make sure you remember to turn that into litres. That's where a lot of people make mistakes. Put that in our calculator, so we're just going to times that number by 0.025. We get 0.0147. Or 0.01. I'm going to round that up to 1.5 to keep it to two significant figures like we have up here. Moles. So our number of moles of potassium hydroxide is 0.015 moles. Now we're up to part D. We can calculate the number of moles of sulfuric acid neutralised. To do this, we need to now look at the ratio. So the ratio of potassium hydroxide to sulfuric acid. If we have a look here, we can see it's a 2-to-1 ratio. We need twice as much potassium hydroxide as we need sulfuric acid. So, to figure out the number of moles of sulfuric acid, we do the ratio of potassium hydroxide to sulfuric acid. In this case, it's 2-to-1. So therefore, our number of moles of sulfuric acid is going to be equal to the number of moles of potassium hydroxide divided by 2. The reason for that is we had twice as much potassium hydroxide as sulfuric acid, so we're going to need half as much sulfuric acid to neutralise that potassium hydroxide, so we need to divide that by 2. We go back, we found that the number of moles of potassium hydroxide was 0.015. It's going to be equal to 0.015 divided by 2. I'm going to use the number that's still in my calculator, so divided by 2, and I get 7.39 times 10 to the minus 3. Moles. Alright, so 39, if I round that off correctly, I'll put that over here, so that's 7.4 times 10 to the minus 3 mole. So I'm going to use that number when I'm doing my calculation. Okay, I'm going to use the number in the calculator when I'm doing the calculation, but that's what I'm going to write down for my answer part D. Last part is to calculate the concentration of the sulfuric acid. Okay, so what I'm going to do is write the equation down, C equals N on V. My number of moles, I just got then. So 7.4 times 10 to the minus 3. Right, the volume that I use, back to the question, is 21.4 mils. Right, so turn that into litres, so volume is 0.0214. Put that in my calculator, so still use the number from before, 0.0214. I get 0.3, round that up to 5 moles per litre. And there we go, we've finished the question. So that's just an example of doing a fairly simple titration question, similar to what you might get in our homework or a test. That's it for Flipping Science today. See you later.